Welcome to Minukuu tutorials. In today's tutorial, we're going to look at how to omit subjects with missing data, or delete, or if you want, remove missing data or NAs from your data set when making calculations, right? So without wasting my time, I'm going to import the data set and let's start. So I've named my data set base, and it's a CSV file that I have on the desktop. So I'll just simply let me execute this code to read our data set into R. Okay, I've done that. Now to see our data set, I simply have to say print, in lowercase, print, into brackets. We look at our data set base. I named it base, so I'll simply run this code. Okay, and here is our data set. So the data is composed of 4 columns or 4 variables. We have the names of the different students, for instance. Then we have their ages, the sex, and then the BMI. So if we want to know how many subjects there are, then we can just say dimension into brackets base, and it tells us that we have how many? 15 subjects or 15 students and 4 columns, 15 lines and 4 columns. Now let's examine our data set properly. As you can see, there are missing values for all the 3 variables. So when we look at age, we will realize that this person here, Badu, has a missing value for age. We could also realize that Thomas has a missing value for age. And we can also realize that Gavi has a missing value. A couple of people, Kofi also has a missing value. We come to sex, and we will realize that Kujo has a missing value for sex. That's why, but you see that in the case of qualitative variables, R doesn't usually put NA. It just leaves it as space, but for variables like BMI or age, which are quantitative or numeric, it puts NA. Okay, now we're going to look at 2 major ways of handling missing data of this sort. Remember, we have different types of missing data. We have missing completely at random, missing at random, and then missing not at random. And then we can use different strategies in managing, especially data that is missing at random, be it especially missing completely at random or even missing at random. Generally, we can impute we can imputate these data. We can do what we call multiple imputation, where we can actually replace these values, and many other different methods, but the basic method that we are going to look at today is how do we analyze just available data, that is by omitting subjects with missing data, or how do we also make calculations by simply ignoring or removing or if you want, deleting missing values within a particular column. So for instance, if we want to calculate age, we simply ignore the NAs and we calculate the age, the mean age. For instance, we want to calculate the mean age, or how do we delete how do we just omit all subjects with missing data, like Badu will be omitted, and which other person Sandong would also be omitted. Though, for instance, Kojo would not be omitted because Kojo has a missing value for sex, which is a qualitative variable. We don't usually calculate mean for sex, so mean, for instance, so that's why it's not even written as NA here. Okay, so without wasting my time, let's start. So the first method that we're going to look at is omitting, right? So omitting subjects. Or if you want lines, the subjects here stand for the lines, or I said lines, the rows, right? The rows, and the columns represent the variables, right? Okay, But before that, let's try to calculate the mean, for instance. So let's just try to for the benefit of the doubt, let's just try to calculate the mean age and see what happens, or the mean BMI. So if I should say mean into brackets age, so I will say what, base, which is the name of my data set, $age. If I should run this, let's see what happens. R has given me NA. Why? Because of the missing data within your what do you call it, your variable age. The same thing applies to what do you call it, BMI. So if I should say mean of BMI base $BMI, let's see what happens. Sorry, I doubled the bracket, sorry for that. The same thing happens, NA, because we have subjects like Sandon with a missing value for BMI. Okay, now let's look at the first method. What I would like to understand is that with the first method, which has to do with, let's say, method one, which has to do with omitting the subjects with, or the rows with missing data with NA. It will only omit the, subjects with missing data for numeric variables, not qualitative variables, right? Okay, so with this method, let's see what happens. All we have to do is that we'll create a new data set, and we'll name that one, for instance, base 1. So we say, for instance, base 1 is equal to, less than and dash, or you say equal to, then we say NA for missing data, na.omit into brackets, then we write the name of our initial data set. So we want to omit all subjects with missing data within this particular data set. So na.omit into brackets base. Let's see what happens. Okay, that is done. Now let's print this base 1 and see what happens. So let's say print base 1. If I should run this, you see that now a couple of subjects have been deleted, or you could say deleted or have been omitted. It's better to say they have been omitted, right? So we have, for instance, subject number 7 is no more, number 10 is no more, number 7 is no more, number 10 is no more, from 12 to 14 are all gone. You see, if you to confirm this, you can just say dimension of, let's say, base 1, which is our data set, our new data set after omitting. You see that we now have 9 subjects and 4 is still 4 variables. But we have lost how many subjects? About 6 subjects. Initially we had 15, now it's 9. Okay, now let's calculate the mean. But look at the data set, you realize that, like I told you, for qualitative variables, they haven't omitted Kojo because Kojo did not have a missing value for age and BMI, you see. So, but now let's move ahead and see how we can calculate the mean now after having omitted the missing values, right? So to calculate the mean, we simply say mean once again, then we say now base 1. We are now to calculate mean of our base 1, or if you want, of our new data set after omitting the subjects with missing values. So we want to calculate the mean age, and we also want to calculate the mean BMI. Okay, so if I should execute these two, see what happens. We have our mean age of the 9 subjects to be what, 22.7, and then the mean BMI for the 9 subjects to be 24.4. Notice that we're going to calculate after, notice that after calculating after using the second method, we are not going to get the same values. Why? We'll see that later on, and I'll explain to you why. So let's move to method 2. So this is the first method. This method is what we often term as calculating, or let's say I don't know what to even call it. It's often termed as analyzing complete data. Complete data, that's individuals with complete data. Now let's move on to the next method, which is method 2. Method 2. So method 2, what we're actually going to do is that we will not omit subjects with missing data. Rather, we will ignore missing values. Do you get what I'm saying? Instead of omitting subjects with missing data, we will rather do the calculations and ignore subjects with NAs. Not that we ignore subjects with NA, we just ignore the values, NA values, right? Or if you want, ignore subjects with NA values. So for instance, we calculate the mean. For just the mean, we just calculate the mean, but we ignore or remove the NAs. You see? And we come and calculate. But now what is the disadvantage of this method is that if you are using this method, then what that means is that at the end of the day, you have your parameters will be calculated on different subject effectives, or if you want, different subject counts, because I haven't deleted the what do we call it. What that means is that my mean age will be calculated on, for instance, how many subjects. Here we have how many? We have about how many missing we have. Okay, this person will be, Kofi will be ignored, Kojo will be ignored, Thomas will be ignored, Trey, Badu will be ignored, and who else? So far about 4. Let's just take it is 4. So 4 people will be ignored, for instance. When we come over here to BMI, only 1 person will be ignored. So it means you calculate your BMI for just 11 people when your mean age will be calculated on 11 people, while your mean BMI will be calculated on let's say 12 people. You see? So it means we are going to calculate our parameters on different effectives, and that doesn't really sound good. Or if you want different subject counts, different, you see. So and by analyzing only complete data, that is by deleting or omitting subjects with missing data, that one too, that's the best way, because at the end of the day you have equal number of subjects, but a disadvantage is that we're going to lose test power. Let's assume we're going to do some inferential statistics, I don't know, or estimate the population values. At the end of the day, we'll lose test power because we've lost a good number of subjects too. So that's why most of the times, if the data is missing completely at random, or even missing at random, we often do multiple imputation to replace the missing values by some standard values. That's not the purpose of this tutorial. Like I said, it's just to see these two simple methods, how we can do our calculations in case we have missing data. We've looked at the first method, which has to do with omitting. The second method that we are going to look at has to do with ignoring, or if you want, removing missing values from the columns and going ahead with our calculations. So let's do that. Now, if you want to calculate the mean for the mean age, all we have to do in this method is to say mean into brackets, then we say what? Base. So now we are using the initial data set, base $, then we say age, for instance, then we put comma, and then we indicate that we want to remove all NAs for H. So we say remove. So what it's going to do is that it is going to ignore all NAs when calculating the mean, so it will not give us an error or NA. So we say remove na dot remove is equal to true, and we're going to do the same thing for BMI. So mean into brackets, base, use the $sign to select BMI, we put comma, then we say na dot remove is also equal to true. Now let's select these codes, 2 codes, and then execute. Okay, so now we have our mean H and then our mean BMI. But now let's see what happens. Now compare these two values here that we have here. So see that the mean H, when we just ignored missing values without deleting or omitting all subjects, what happened? We had mean H, for instance, to be what, 23.4, and then mean BMI to be what, 24.41 something, 416. Now let's look at these values over here. When we did the calculation after omitting, you see that we had 22 point something and then 24.44. So it's definitely not the same. You see? And what accounts for this difference? It's simply because, like I told you, when omitting data, for instance, when we omit subjects with missing values for those numeric variables, for instance, let me go back. When we omitted somebody like Kofi, Gavi, Victor, Thomas, when we omitted these people, what that means is that we just lost data. Like we just simply delete the whole row, So when we delete the whole of the row, what happens? For instance, what that means is that by doing this, it affects the whole data, So when you do this, for instance, if I should delete somebody like Badu who has an NA for H, it's gonna also take away his BMI value. You see, when you delete somebody like Thomas with a missing value, it's going to take away his okay, Thomas had missing values for the two, that's both H and BMI. But if we delete for Gavi, it's going to take his BMI. If we should come and delete for this guy Sandong, he had a missing value for BMI. If we should delete it, then it means it's going to take his H value. You see, so that's why this, at the end of the day, we have a data set of just 9 people, and when we did the calculation, we had these values. And but the other method, what it does is that it's not going to actually delete the subject, so it's just going to calculate per variable or per column. So it's only going to remove the NAs within the particular column and do the calculation. So this is what accounted for the difference. And generally, for statistical purposes, we don't usually ignore, unless you just want to do some random calculations. But generally, we always, if in case we are not going to do multiple imputation, that is to replace the missing values by some standard values, if we are not going to run a multiple imputation model, then all we have to do is to analyze complete data. That is by simply, most of the time that's what we do. We simply ignore subjects with missing data, not ignore as such, we delete subjects with missing data, and then we analyze only subjects with complete data. This is the case where the data is missing at random, and then you have a very large data set. You can do this. Else you have to do multiple imputation. Maybe in future tutorials I'll show you how to do multiple imputations. But if you want to just calculate mean of a particular column. This has nothing to do with, you are not going to do any inferential statistics where you don't want, so it's just something. So you just want to calculate a mean age without really taking into consideration the fact that, okay, if I should calculate mean age with a different effective or a different a number of subjects, and also come and calculate BMI with a different number of subjects depending on how many missing values we have for each column by using the second method, then if you know this, you are not going to do any inferential statistics, just any ordinary kind of thing. You just want to know what's the mean age irrespective of the number of subjects on which is going to be calculated. You don't, then you can come in for the second method. I hope my explanation was clear, and thank you so much for watching. Please subscribe. Bye.